All right, we are going to be doing science. Okay, so you need to be on page 64 in your book. Adjust this camera angle a little better. There we go. All right, page 64 in your book, we're going to begin reading. First of all, let's read the terms to remember together. Water vapor. Water in the gaseous form. Remember we talked about states of matter, solid, liquid, and gas. So water vapor is water in the air. Is there water in the air right now? Is there water in the air right now? Yes, there is. All right. There is water in the air. Can you see it? No, because you can't see a gas. But there is water in the air right now. So even though you cannot see it right now, at this very moment, there are drops of water in the air. All right, they have evaporated from somewhere and there are drops of water in the air. Sometimes there is so much water vapor in the air that you can feel it. You go outside and it feels very sticky and heavy. The air feels sticky and heavy. There's lots of water vapor in the air. Okay? Now if it's raining, that's water as a liquid. But right now, there is water in the air. Even though you can't see it, there is. There's water vapor in the air, so that's water as a gas. All right, then the other one is wind, which is moving air. That makes sense. Moving air is wind. Water. How does water get into the air? You cannot see it, but water is always in the air. You remember that water can be found in 3 states: solid, liquid, or gas. Water is a liquid when it is rain. It is a solid when it is hail, snow, or sleet. There is plenty of water on Earth because of the oceans, lakes, rivers, and other bodies of water. The sun's heat energy changes it into a gas called water vapor. So how does the water get into the air as water vapor? Because of the sun. The sun heats the water and the water does what? Evaporates. Do you guys notice in the word evaporates is the word vapor? Evaporates, water vapor. All right, wind. What makes the wind? Wind is moving air. All air has weight or air pressure. The sun's heat energy warms the air and makes it become lighter. Because warm air is lighter than cold air, it rises. As the warm, lighter air rises, cold, heavier air rushes into the place where the warm air had been. This action goes on in a continuous cycle. The Bible tells us that the air or wind is in constant motion. So even if the air is still where you are, somewhere there is wind, right? Always. So think of a hot air balloon. What makes a hot air balloon rise? Heat. They heat the air in the balloon, and as they heat the air in the balloon, hot air is lighter, and so the hot air balloon will rise. Well, it's the same with what makes wind. The sun is heating some air, and that air, when it gets heated, it will rise. Well, when something rises, something has to fill its place. So this cold air moving in, that is making wind, right? So that's how wind is made. Read the verse at the top of the next page that goes along with what we just said about God said there's always wind. The wind goeth toward the south and turneth about unto the north. It whirleth about continually, and the wind returneth again according to his circuits. All right, now we were talking about air pressure. We said that air has weight, all right, making air pressure. So I have an experiment that we're going to see. All right, so I have here, this looks like water, but it is not water. Okay, I put vinegar in here. Okay, so this is vinegar and this is a balloon, but this balloon is not empty. It has something in it. And right now, that's the only thing in that balloon, right? Okay, so I'm going to take and I'm going to dump what's in the balloon down into the vinegar. And there is going to be a reaction between the baking powder, right, and the vinegar. All All right, so as there is a reaction between the baking powder and the vinegar, what do you see happening to the balloon? All right, even my water bottle is getting fatter because it was crumpled from where I had pushed on it and it was crushed, but now it's not crushed anymore. But the reaction between the vinegar and the baking powder makes carbon dioxide, which is what's filling up the balloon. So that's making air pressure, okay? So there is our first experiment. We have two. One of them we're actually going to start today, but we definitely cannot finish it today. All right? So that is our first experiment showing air pressure. If you look at the bottom of page 65, it says the baking powder and vinegar react with each other and produce the gas carbon dioxide. As the carbon dioxide molecules fill the balloon, air pressure is created to inflate the balloon. And by the way, this is the best it's ever done because I put more baking powder in the balloon this time than I ever have before. Last year when I did this, it only filled up a little bit. This time I got it to fill up more. So that turned out pretty cool. All right, turn page. All right, true or false? Water is always in the air. True. Even though you can't see it, there's always water in the air. Number 2, the sun's heat energy changes liquid water into ice.
False.
No, it changes it into water vapor. It doesn't make sense that liquid water is changing to liquid. Whoever said that. The heat energy changes liquid water into water vapor. All right. Wind is moving air. True. Cold air is lighter than warm air. No, cold air is, if it's not lighter, it is heavier. The opposite of that would be heavier. Warm air is lighter, but they didn't say warm air is lighter. They said cold air is lighter, so cold air is heavier. What is the source of energy that makes heat, water, and wind to create all kinds of weather? So where does that energy that makes the heat, water, and wind form into weather? Where does the energy come from? The sun. The sun. All right, let's read the next terms to remember. Meteorologist, a scientist who studies weather, forecast, weather prediction, because that's all they can do is predict. They don't know for sure what's happened. They can study science and study weather patterns, and they can make a good guess, because that's all a prediction is. It's a good guess as to what's going to happen. And then evaporation, the process by which liquid water becomes water vapor. And there's where you can see the word vapor right there in evaporation, because it's taking liquid water and turning it into a vapor or a gas. Meteorology. As we learn about how weather works, we also learn how to collect and graph weather data. There are always weather scientists doing this so that we know what kind of weather to prepare for. A weather scientist is called a meteorologist. So when you watch the weather, not always, but a lot of times that person giving the weather is a meteorologist, okay? You don't have to be to tell about the weather, but sometimes that is what they do. They are a meteorologist and they tell the weather on the news. Meteorologists collect weather data from satellites, weather balloons, and weather airplanes. They have many different methods to forecast or predict weather. You have probably seen a meteorologist give your local forecast using Doppler radar. And you see that picture right there. That man is pointing to the computer screen, but that is what they call Doppler radar, which would be coming from a satellite, and that would be showing a storm. That looks like a hurricane, okay? Now, the next page is just talking about making a weather graph. We are doing one for temperatures, so we're going to skip that page and go straight to page 68. Turn to page 68. The water cycle. The atmosphere is always at work, making sure that Earth is neither too hot nor too cold. The air is always moving to create wind. Water also moves in a continuous cycle. Rain helps to keep freshwater sources clean. People and animals cannot live without water. Plants cannot grow without water. God gave the earth a water cycle because all life depends on it. All right, so first it starts with evaporation. Puddles. Whether you like to splash in them or walk all the way around them,
are only for a little while. When they dry up, where does the water go? Remember, matter cannot disappear, but it can change state. The water from that puddle went back into the air as water vapor. We call this evaporation. Evaporation is always happening on Earth. Heat energy from the sun warms the Earth's water. Heat energy causes tons of water to be evaporated each day from oceans, lakes, and ponds, and even little mud puddles caused by the rain. Plants also give off water into the air. All of this warm water vapor rises high into the air. All right, so think about corn. How many of you have ever seen corn growing? How many of you ever looked at the corn one day and you saw that the leaves of the corn were wide and flat? How many of you, when it didn't rain for a long time, you drove by the corn and you saw the leaves were starting to curl up? All right, because even those leaves, water is evaporating from those leaves, and so when they don't have enough water to give off, they start to curl up a little bit to try not to give off as much water because they're trying to protect themselves. All right, now the other experiment we're going to be doing, we cannot do it right away. It says, practice the scientific method with evaporation. Does the water evaporate more quickly in a warm or cool place? All right, so true or false? Number one, heat energy causes evaporation. Is that true or false? True. All right, so where is water going to evaporate more quickly? In a hot place or a warm place. You can just say in a warm place, okay? So water evaporates more quickly in a warm place. So we're going to place water. I've got 2 cups up here, and we're going to place water in 2 different places. One of them is going to be cool and dark as I can get it, and one of them is going to be warm and sunny. So which one do you think is going to evaporate more quickly?
Warm and sunny.
Warm and sunny. Since we know heat evaporates water, we are going to assume that the water in the warm and sunny place is going to evaporate more quickly. All right, so I have 2 cups up here, and I'm going to fill both of them. All right, when they are side by side, I already measured it. When they are side by side, when they are side by side, the mark is at the same place. I have written shade on this one. I'm going to find a shady place over in the corner of the room to put this one after I fill it up with water. And this one says sun. It's hard to see, but we're going to put that in that sunny window back there. And you better leave it alone, okay? So it's going to go in that sunny window. Now, not every day will be sunny, but most days when it is sunny. So which one do you think is going to evaporate more quickly? The one I put in the sunny window or the one I put in the shade?
Sunny window.
All right, so we'll have to see, and we will keep pulling it out every now and then to check it and see. All right, the other thing we need to do is notability. You have out your temperature charts,
yes.
And we are going to do the temperatures for today. Alright, so you need your red and your blue. And at the bottom where it says number 2, we're going to write the date for today. So what's today's date? 9/21. So you're going to put this right where it says number 2 at the bottom. 9/21. All right, let's go back up to here where it says title, and we're going to write daily high slash and then the low temperature. Temperature. So daily high slash low temperature.
take it away from here until everybody's gotten that written, so. Raise your hand if you need more time. All right, well, you don't want to look at writing. Come on, get busy writing. I got so many people that are already finished. You good? All right, good. All right, now let's go to the second line. Remember, we're going to follow line number 2 up. And when I look, it says that Tuesday's high is 81 and the low was 69. All right, so 69 is really close to 70. So remember, you're going to use your blue. Follow the line number 2 up and put it a little bit below 70. Because 69 is a little bit below 70. And then the high is 81. So this time, switch to your red and go just a tiny bit above the 80. All right. So what did you notice about both? Between yesterday and today, both have done what?
Moved. One was lower.
Which direction? Which direction have they moved from since yesterday?
Up.
Up. The low went up a lot and the high went up a little. All right? But they both have gone up. All right? So we'll have to wait till tomorrow to see what happens tomorrow. All right. So that is it for the day. Thank you.